Hi everyone, welcome to my YouTube channel Take Data Engineer. So today we will see what is columnar storage and why we are using that. What is the difference between row based and column based storage, and what are their disadvantage why we are using in big data processing. Okay. So we have two types of storage. Either we can store the data in row format or we can store in the column format. Okay, so columnar storage is a data storage format where our data is stored column by column, okay, rather than row by row. So in different in traditional system, I can say RDBMS and all, you are storing the data row by row. Okay, so in column based storage they have certain advantage. Because of that, in big data and analytical system we are using the column storage. Okay. Okay, so let's discuss this advantage, why we are using column storage, and then we can further proceed. So there are lot many disadvantages like efficient compressions. They have we use the efficient compression for that data if we are storing column instead of row. We have improved query performance, efficient aggregation and filtering, and optimized for analysis. So let's discuss first one, efficient compression, what it mean. So since column storage groups similar data together, what it means, suppose we have name, column, age or city. So similar type of data, it will group the similar type of data. Suppose we have only the city data, okay, so it will take city data and it will do whatever the compression we are using for some same city. If there is a duplicate name coming, so it will use the same compression techniques, okay, same compression and same encoding also. So since column storage group similar data together, it can achieve better compression ratio. Okay. Like that's what I already told. If a column contains many repeated value, a compression algorithm can efficiently encode these repartitions. Okay, if name is same or city is same, suppose city two times coming Bangalore or Delhi, so if one Delhi they have encoded, similar way they can encode the other Delhi also. So that is efficient compression we can use. Improved query performance. So columnar storage is particularly beneficial for read heavy operations. If you have to read heavy data, so we can use that, such as those found for analytical system. Okay, so in analytical queries we are using basically this one. When a query needs to access only a few column of large data set, suppose you have 2000 column, and that if you wanted some subset of column only, so you can use that particular technique, columnar storage, that is beneficial. But in row storage, what we are doing earlier, if you have to take some subset of data, so you have to just we have to like scan entire row. But in column storage you can go particular column and you can fetch that data. Efficient aggregation and filtrations, again for operations like summing, averaging or filtering based on a specific column, columnar storage can be more efficient since all the value for a column are stored together. Okay, so that's why we are using this columnar storage. Now again the other benefits are like optimized for analytics. So columnar storage formats are designed to handle large scale analytical workloads. Okay, so they support efficient operations on large data sets, such as those used in data warehousing or any business analytical applications. So that's why we are using this. And then a schema evaluation and flexibility. So many columnar storage formats support schema evaluation, allowing you to add or remove column without affecting the existing data. Okay, so this flexibility can be useful as your data requirement change over the time. If some changing data is coming, incremental data, watermark data, then you can that is storage will be beneficial. So these are the advantage we have. Instead of row based, why we are storing everything in column based, we have this advantage: efficient compressions, improved query performance, efficient aggregations, filtering, optimized for analytics and schema evaluation, and flexibility. So these are the advantage for columnar storage. Now we can see by a simple example how earlier we are storing as a row based and column based. So suppose we have a data set called id, name and their salary. Okay, so id would be 1, name would be Abhishek, and salary would be 70,000 suppose. So in row based we are each row, whatever the data frame we have, each row we are storing the row 1, row 2, similar like that. But in column based storage, if you'll see here, first we are taking id as a column 1, so id we are storing similar way. In the new column is name Abhishek and Harish we are storing in a different one. It's like named column, and then salaried column we are storing as 70,000 and 80,000. So there is a different way to store row, and in row based storage there is a different techniques we are using, and in column based storage we are storing the different way. Okay, each column is stored in a single line, and then new column will come here, first row will store, then second row, then third row, similar to that we are storing. It is similar to row based and column based matrix storage also. Okay, so these are the advantage of column based storage. Now there is a file format called parquet file which we are using in industries also. So this is also column based storage. So why we are using that, we can see how we are writing the data, reading the data from parquet file format. So basically this parquet file format is a column storage, and we already know that what are the advantage of column storage. This parquet was designed for optimized purpose. So earlier this was developed by Twitter and Cloudera, and now this is under the Apache Software Foundation as a open source. So how we are reading or writing the data from parquet, it is similar to that. We have read function, spark read and spark write we have. So only the format will change. Suppose how we are writing for csv, it's a spark dot read csv. Similar way we will write for spark dot read parquet also. So will create before reading or writing the file, we'll create the spark session and all. So I am not discussing that part. What we will do here, we will write like df equals to spark dot read parquet, and whatever the file positions we have, file locations we have, file path we have, we will give the path to your parquet file. It is local or somewhere else. Then after reading the file we can do the df dot show. So based on that we will display the data. So this is the simple syntax for writing the parquet file. And then again it's come to writing the parquet file also. Similar to that we have df dot write parquet, and then we can pass the location, file path location, and then we can write the mode basically specify how to handle the existing file. Okay, so if there is already data in your file, if you wanted to overwrite or append or ignore or error if exist, so this is the default behavior when there is error comes uh, if data already exists. So these types of mode we are using: append, overwrite, ignore and error. So this all we can choose the mode while writing the data. In mode you can give overwrite, we can give append, we can give ignore based on your requirement. Okay, this is one syntax. Df to write parquet, we can give the file path and mode equals to overwrite. Or other way we can do the df dot write mode, and then we can pass under mode functions df dot write mode, we will pass the append as a parameter, and then dot parquet. How we are writing in csv, df dot write dot option we are passing multiple way, then we are writing dot csv. Similar to that we have df dot write dot mode. Under that mode we will pass either append or overwrite or ignore or error, and dot parquet, and then pass the file path. Okay, so this is also a way to write the data in parquet file. Okay, then there is a advantage that suppose you wanted to do partitioning and only the partition data to be stored in the destination file system. We have 10 columns suppose, and we wanted only the age column to be stored somewhere for some analysis purposes. Okay, or some age factor and some different factor, it's like age and then their disease rate or something, any column thing, anything if you want to store. So you can partition data one or more column, you can choose one or more column to optimize query and manage large data set. So you don't have to store the entire data set to do some business analytics or do some or bring some insights from the data. What you have to do, you have to do the partitions from data based on the column. Okay, so how we will do that? We will do that df dot write dot partitions by. If you wanted to select one column, we will do column name, or you can select multiple column, we can pass the multiple column dot parquet file. So where what it will do, basically from your parquet file, from your data set, it will take that particular column and store to the parquet file. So that way we can do the partitioning. That will helpful for analyzing the data. Instead of taking all overhead data, we can just only take the data which is required for our I can say our dashboarding, or our whatever the computation we wanted on that data, we can do that. So that's why we are using these partitions by functionality also in column storage. Thank you, thanks for watching.